Newton's third law of motion. The aim of this experiment is to investigate force pairs acting on an object. Newton's third law of motion states when a body A exerts a force on a body B, the body B will exert an equal and opposite force on body A. With this, we expect that forces in a force pair will have equal magnitude but be opposite in direction.
In this demonstration, we're going to have a look at Newton's third law. Now, you should know what Newton's third law is all about. Over here, I've got two force sensors. And what I'm going to do is I'm going to make them one exert a force on the other. And you should be able to tell me what those should be according to Newton's third law. And these are also connected to a computer. And if you see on your computer screen, I've got force 1 and force 2, which will illustrate the forces that these exert on each other. But I'm not going to make them pull on each other. I've got a piece of elastic, and I'm going to join them using the piece of elastic. And so these, force 1 and force 2, are going to exert a force on each other. Before I put the elastic on, they are both reading 0 because there is no forces exerted. Now let's pull them one against the other and have a look there. There's a slight, very small margin of error, but have a look at those forces and have a look at the sign of the other one. If we actually increase the force, just push it over there, have a look at the forces compared to each other, and have a look at the sign of the other one. And this you should be able to explain using Newton's third law. Let's try one more, see if you can have an even greater force. Have a look at that. All right? See if you can explain this using Newton's third law.
As you look at the experiment on the screen, the sensor on your right-hand side we will call sensor 1. The sensor on the left-hand side we will call sensor 2. For short, we will call them S1 and S2. The two force sensors are joined by an elastic band which creates the tension between the two. We choose the positive direction to be to the right. Force sensor 2 measures the tension to the right, and force sensor 1 measures the tension to the left. Now we can identify the force pair on the elastic band. Force 1 is the force measured by sensor 1. This is the tension to the left due to sensor 2 pulling on sensor 1. Force 2 is the force measured on sensor 2. This is the tension to the right due to the force of sensor 1 pulling on sensor 2. When we look at the results, we can clearly see that the force of sensor 2 on sensor 1 is approximately equal to the force of sensor 1 on sensor 2. The only thing that differs is the sign. Force 1 shows negative and force 2 shows positive. In each of the cases, they are approximately equal. The negative sign is due to the direction. Force 1 is to the left and force 2 is to the right. We can conclude from this that the force that sensor 1 exerts on sensor 2 is equal and opposite to the force exerted on sensor 2 by sensor 1. This confirms Newton's third law of motion.